Okay, today what I'm going to discuss is yeah. So I got some feedback from friends. So basically, I little going little faster. So I'll I'll make my uh, the pace is little slow. So we last two session we created a virtual machine with the Ubuntu operating system, and then we installed Hadoop. Okay, so we installed two components. One is HDFS, and then another is the Yarn component, and with MapReduce. So these three components been installed on the virtual machine. So and we were able to start the different processes from each component. So if we just show what we did yesterday. Okay, so we were able to start uh, the SDFS processes, which is a name node and data node and secondary name node. And similarly, we were also able to start the resource manager and okay, so we are also able to start the yarn component with the process resource manager and node manager. Okay, so that's what we stand in. So we completed the installation. Now we'll actually learn about a few more concepts in HDFS, Hadoop Distributed File System, and then we go back to the we'll go back to MapReduce to learn about how MapReduce works, and we'll go and see we'll write a MapReduce job, and then we'll execute it. So I'm going to just give you the I will show you the MapReduce program, or we write MapReduce program using Java as well as in Python. Okay, so Java, if you don't want to just or not, if you are actually okay not interested, I'll just show you the at least the high level what is there in Java project. Anyway, we are going to write into Python, which I think some of you are familiarized with the Python. We'll be writing. I will explain you in detail about Python MapReduce program, but I want to show you the Java MapReduce so that you can actually understand basically, because we express everything as a class and objects uh, in object-oriented programming. So all your classes are all your MapReduce classes are available in Java. So just to have a see about it, but we will anyway will write the same functionality. Will achieve the same functionality using Python. Okay, so that is the plan. So let me know if you have any questions. Okay, now I'll move back to the HDFS. So say example, I open my virtual machine. As I mentioned, you can interrupt me anytime and you can stop me if you have any questions. Okay, so what I'm going to do is I'm going to start my that SDFS services or the processes using a command called startdfs.sh. So I'll increase the font size, appearance. Okay, there's a command I said start dfs.sh. So this is going to start the HDFS processes. Okay, so this is started. I will start hyphen yarn dot sh. It is going to start the yarn process, which is resource manager, node manager. Okay, so let this get started. So what I want to discuss is, take example of you want to store a file. Okay, I consider there is a file called sample1.txt, which is of around 300 MB. Okay, for just for simplicity sake of explaining, just to take it a 300 MB of uh, file. Okay, so we saw the default block size in Hadoop 2 version is default block size in Hadoop 2 is 128 MB. Okay, if this file I'm trying to copy into HDFS, so first I'll just create HDFS TFS hyphen mkdir hyphen p data map is hyphen p is to create a subdirectories also in the same one command. So if I create this, so there will be a directory called input inside the MapReduce directory, and I want to place this file into this directory. So example, like I do HDFS DFS hyphen. You can use a two command is there. One is hyphen put, another is the hyphen copy from local. Basically, you need to provide the source location. Say example, I have in the current directory, I have the same the sample.txt. So I'll just use sample.txt, or you can give the path wherever this file is there. I assume that it is in current path, so I'll just use the file name. I need to specify the target. Target is our HDFS directory, so I'll place. So what will happen now? So basically, this 300 file will be converted into three blocks, right? Whenever the functionality of HDFS is to store your whole file, split the whole file into blocks and store it on different machines. So that's the HDFS does on different nodes. So what will happen? This 300 MB of file will be converted into block one. Okay, around one. It's because the size is fixed size, right? So 128 MB, and block two will be again 128. Okay, and block 3 to 6 will be the consumed space will be uh, uh, 44 MB, but actually to by logical bound logically it will allocate it will split by two, 128 MB, but because this file content is only 44 MB, it will consume only 44 MB, but it will allocate a fixed size only 128. The remaining space will be used by the other files if you want to store it on. Can be used to, the remaining space can be used by the file system for storing other blocks. Okay. Now, so basically our file is converted into three blocks, and this has to be stored on this has to be stored on these different nodes. Okay. Now, so this is the scenario. Okay, and think this is a name node. So we have a name node here, and we have a data node 1, we have data node 2, and we have data node 3. Okay, so when we use this command line utility DFS HDFS, what this example so this is my example, this is my edge node. This is my edge node. I'm running HDFS commands here. Okay, so when we run this command, HDFS DFS hyphen put the sample.txt from this file into this directory. So when you run this command here, so the HDFS client, it communicates to the name node, okay, and tell that I want to copy this file into HDFS. So what name node does is, name node add as information, because it's a master process, it has the information about the cluster nodes, which node has a space to store the data, okay, and it give the instruction back to the HDFS client, okay, saying that there is a space availability in these nodes, and uh, this file is maybe this file is will be created as three blocks as per size. If you have 300 MB, so this file will be converted into three blocks, and you store these three blocks on three different nodes. Okay, to instruct this uh, uh, block has to be stored on data node 1, and then this will be in the data node 2. This is in the data node 3. Right, so it gives the matrix to where this block has to be stored. It gives the instruction back to the HDFS client. The name node will not go and store the data here. Now the HDFS client responsibility takes the matrix which name node has given, go and copy the block 1 here, and block 1 to here this node, and blocks 3 to this node. Okay, so this will store block 1 here, block 2 here, and block 3. Okay, the HDFS client responsibility to store this data, and also the name node also instructs based on the replication factor. It also tells that store the data, the replicated data, the copy of the block into other nodes as well. It gives that information also. Okay. So if you have any question on this, I'll just show you the same representation in a slide in different way. If you have any question, just stop me here. So this is just what we have it in HDFS side, name node, data node. The name node is going to have a metadata and block location, and the data node is going to store actual blocks. Okay, now this is read operation. This is what I was talking about in this diagram. Okay. So you have a HDFS client which give me the location where I want to store this file, and give me the information what I have to do. So the name node gives the set of metrics to, or maybe the information, how this file, like how many blocks for this file, and where those blocks has to be stored on which data nodes. Okay, so it takes the HDFS client takes the information and copy your block into the respective data nodes. There are two things to note it here. Okay, so the name node instructed, this file will be converted into 3 blocks, and you have to store these 3 blocks into data node 1 and 2 and 3. So what the HDFS client does, the write operation of blocks will be done in parallel, which means block 1 will be stored on this node, the same block 2 at the same time. So in parallel, the block 2 also will be stored on block data node 2, and the block 3 will be in data node 3. That write will happen in the parallelly. So to increase the better performance. And then this is the first copy. The replication, right? The replication does, okay. So if you see here, the block is copied into this node, and the first copy will say example, first copies of block 1 is stored on the data node 20. The second replicated data of block 1 will be stored on this node by this data node, okay, not the HDFS client. The first copy only will be copied by the HDFS client. The second copy of the same block will be done by this data node, and once this is done, then this it will instruct this data node to copy the third copy of the block. So this copying of the second copies of the block 1 uh, done in sequential, okay. So always the first copy of the blocks are parallel, the subsequent copies are all the different blocks will be, the first copies will be done on parallel, and then the second copies of each block will be happening on sequential manner. You have any question on this?
Yeah, Pari, I have a question here.
Yeah, tell me.
So the SDFS client is writing all the 3 blocks to 3 different data nodes, right?
Correct.
So then how is the performance? I mean, the same process is doing, right? Instead of writing into
so
one node.
So basically, see, or else see how this app, if the performance how it is increases. Ideally, the it has to uh, take so it is not going to do complete the first block and then it will start the second block. Not that way. The same process using the multi-threading, it is going to
Okay.
do this 3 blocks concurrently. It is going to run parallelly.
Okay, asynchronous. It will happen.
Asynchronous,
Right?
yeah. Yes.
Okay. So can I? Is there any way to increase the number of processor or something?
Because we have only see when you copy, it is one block will be one. You cannot actually split the data again. Once your file is
Okay.
converted into blocks, that's a end actually.
Okay.
Okay, so furthermore you cannot split it.
Okay. Okay.
Yeah,
Okay. Thank you.
no problem. Does anyone have any question? All right. So if you don't have any question, I'll just continue. So this is how the write operation performs. Write operation happens in the HDFS. Okay. So we have a data. We convert the data into smaller blocks, or they also call it as chunks. In HDFS terminology, it's a block, and we store the blocks into different machines. Now this is write operation is done. So when it comes to read operations, again, so the example what we um, do generally, I just say I put the command here. So I invoke a command called sdfs dfs, and I'll say hyphen get, okay, and I will say location. I will say data, same file I'm trying to get it, data map reduce input, and I'll say sample.txt. Okay, this is the command I want to invoke, right? I'm just running this command. Example, I'm running this command in the edge node. So what happens is it has to go and get this file. So first it will talk to the name node, okay, and then get the block information, because what happens is whenever the HDFS client stores your blocks into respective data nodes, when the write operation is completed, the HDFS client role is completed. Now each data node's responsibility to update the block information periodically to the data node. So it will just periodically send that I have these number of nodes. So the name node keeps track of those block information. That's how the name node will have the block information in its metadata dictionary or metrics, whatever you call it. So it has those information on its namespace, and that's how it is going to give the information whenever the client asks for the new the files to be retrieved. So when you run this command, HDFS DFS -get, and give the entire path of your file. So now the name node has a block information for your file. It will instruct the again the HDFS client, something like this. So it asks for the file, it gives the blocks with the location where it has to read. Now, so it goes and reads your blocks in parallel. The read operation also happens parallel. So like how we write blocks in parallel, similarly it has the uh, block information which has to be retrieved from this data node. Block 2 will be has to be retrieved from this block, and block 3 will be has to be retrieved from this block 3. So it reads the parallel and merge the file and return to the user who's invoked this command. Okay, so this is how the read operation happens on HDFS. You have any question? Okay, so what I will do is there is a file. Okay, so if please rejoin the same link if the meeting closes. What I will do is I will take a one small file. Means we'll take a one file which is to identify how the blocks are stored. Okay, just how internally it stores the blocks. Okay, so and yesterday I showed you one location. Mostly I just put ls. Our softwares are stored on the softwares directory. So cd command generally change directory to the respective directory. So I'll just go to softwares, to ls, and we created a directory called HDFS data, sorry, Hadoop data. I'll go to the directory, Hadoop data, just clear the screen. So you see there is a three directories in this Hadoop data. One is temp, which is for HDFS temp, for storing some temporary files to storing. We are configured this as some temporary purpose, and we configured name node to use this directory for storing the metadata, and we configured data node to use this directory for storing the blocks. So let's see what is there in the inside this. So data node in the data node will have the subdirectory as current, and if you go to, so basically you put ls space the directory you want to retrieve the details from that, and I put the subdirectory current. I run. So currently there's some file, and there are two files only available. And we'll see the name node one.
Sorry, the screen is frozen for me. Is it for all? Or?
Uh, Everyone able to see my screen?
Yeah, we can see your screen.
And are you running any command? I just see ls only.
Oh, is it? Yeah, I ran 3 commands. Okay, let me reshare, stop and share again. I stopped it. I will reshare again. Do you see my screen?
Yeah. Now the commands are running.
Okay,
Yeah.
yeah, no problem. So I just listed out uh, the data node directory and also listed out the data node current directory. Okay, so in the data node right now we have 2 files, BP and it says some external file name and version. And you see in the name node current directory, there is a file called, there are some files. You need to focus on the FS image. There is a file called FS image and edits. Okay, so we'll see more when I will take one probably session and we talk about more about this FS image and edits file. We'll have a separate session on what this file and what is the use of it. So basically for a uh, for your quick at least even quick overview on this file. So FS image and edits are the files which will be used by the name node to store your metadata, and edits will be your you can think as a transaction log. So people who are familiar with the uh, um, database system, you see there will be a database files, right? One is I think uh, MDF file or something is log file. There's a transaction file. One is a data file. I don't remember the other name. Uh, Whenever you perform some operation database, there will be a transactions files, and it will be one main file. Periodically, the it will actually keep the main file will have the actual uh, the final information, and this transaction, every transaction happens, it will have that particular transaction information similar like that. So FS image is your final metadata, and edits will have the that particular periods metadata. Okay, so for now, that's just understand these 2 files. One is FS image and edits. Edits is the that particular times uh, metadata, and FS will image will have the old metadata. Okay, so we'll just later one session I will walk you through the each file what information it contains, how it is handled internally. Now, what we will do is we'll take a one file and we'll copy to HDFS, and what happens on these two directories. Okay, so I'll connect to this. I'm using a utility called WinSCP to upload my file from Linux local laptop, my Windows machine into the VM, which is a Linux machine. I will create one directory here called I'll create data. I'll create one more subdirectory called MapReduce. I'll keep this. Mm, I will download this file. Uh, this is around some 350 MB or something. So that we'll just internally we'll see how many blocks are converted. Okay, so it's around 327 MB. So I will copy this file into my Linux directory. It is in download folder. You see NOSC. It's basically a trading data of New York Stock Exchange. Okay, we copied here. Okay, now I will go again. I will just try to yes. There is a if you want to order your files from Linux directory based on date, so you just do ls for listing your files or directory. If you provide option -lrt, ls space -lrt and give the path, it is going to list all the files based on the timestamp. So okay, now time is 9 o'clock. So you see some of the files till 8:40. Okay, after 8:40 there is no files. This is the name node directories, and the directory which is meant for name node, and also we'll see the data node current directory. So here also after 8:40 there is no files written. Now what we'll do is we'll invoke a command. We'll copy a file into HDFS. So before that we'll create a directory in HDFS. Okay, let's check HDFS DFS -ls, and I'll put slash to check what is my what are the directories available in the root directory of HDFS. Okay, so the only 1 minute left. Please stop this. I will stop this session.